Now, hopefully this is fun and interesting. This is a project that I've been working on because, well, let's see. 5 years ago when I was working at a company, it was useful to have really good tests around the project, and we started doing things like recording our HTTP sessions so we could play them back in some of our tests when we wanted to figure some things out. At my last employer, we wanted to start putting together some things to be able to develop new APIs, and it was useful to have mock APIs to work against to begin with. And then here, we've been working on a number of things, particularly some new APIs while we were building a new front end, and we found ourselves again needing to mock stuff to be able to work this out. And we didn't have organizational buy-in when we first started this out, and so I started just writing this on my own, and Ben was encouraging of this. Started writing a project called Satire. Now, let's talk a little bit about that. See if I can actually do a presentation on my Windows laptop, which I own strictly to test on Windows. So here we go. Satire, the use of irony, sarcasm, ridicule, or the like in exposing, denouncing, or deriding vice, folly, and so forth. This definition was pulled directly from dictionary.com, and it describes my life. Not really, but I thought it was perfectly appropriate for mocks that were intended. A module that enables the use of mock HTTP calls, proxies, and the like in exposing, denouncing, deriding vice, folly, etc. in your application. So, hence the name Satire. Pictures of onions. These were taken this morning on my kitchen table. They're mostly evidence that I was doing something this morning. No, actually, onions, what do they have to do with testing? Does anyone have any ideas why I might pick Edmundo?
This is just a shock. They make you cry.
Testing makes you cry. My experience not testing makes you cry too. So you can pick when you want to cry.
All right, yeah.
I prefer to cry sooner than later, right? Rather than cry because my user found a bug, I want to cry because my QA found a bug, or even better, cry because I or my coworker found a bug as we're writing the code.
It has layers.
Yes, testing has layers. Testing has layers. We have different types of tests, and I'm going to describe these. I have found in researching tests, different people name their tests different things, and these are my names for different types of tests. They are probably wrong, but they describe what I'm trying to describe. So have fun with that. Unit tests, functional tests, visual regression tests, integration tests, end-to-end tests, smoke tests, and production monitoring. All of these provide different layers of visibility into testing as an onion. They provide different layers into visibility into what's going on with your application. Unit tests. I'm giving away the answer to this question, but what are unit tests? Edmundo, go ahead.
I might be wrong, but the way that I learned it is you are just using one specific component, not the whole application, but just a specific part or a specific unit of the whole application.
Right. I pluck a piece, as I put here, a module, a function, a piece of my code out, and I test just that. Somebody posted on the Utah.js Slack a little while back this great GIF of a man doing push-ups as a GIF of unit tests where legs were doing push-up. No, legs were running.
Yeah.
The chest was doing push-ups, and the head was watching a video or something like that. Each of the units was doing something and was accomplishing what it was supposed to, but they were in isolation from the rest of the body. It's a funny use of satire, not my satire, to explain the distinction between a unit test and a functional test, or an integration test. So a functional test takes my whole application, this might be my whole code base, and tests it as a unit. These tests, so a unit test is set up so that function or that module is going to have a specific API, and you test that when you use that API, you get back the result you expect. A functional test considers your whole application. It integrates the code within your code base as one API. And so you test the functionality of that application in isolation from other services that it might call, from other things that it might depend on. These often get called integration tests, and the only reason I've avoided that is because I have a QA or a software engineer and test coworker who uses that term to mean something else, which we'll also discuss. Visual regression tests are a specific class of functional tests. Have anybody ever done this? Ben has done this. Ben knows exactly what these are. Ben, can you describe?
For visual regressions, you push a new version of your code base, everything looks great on your machine, and your client's using old IE, and it just blew up. So, something happened, right?
Right.
The version of this is a cross-browser testing in a way.
So visual regression tests are particularly interested in the visible rendering of a web application. And as Ben talked about, cross-browser testing is an important part of this. What you're trying to accomplish with a visual regression test, when I worked at Ask.com, we did this with film strips through browser sync. There are many ways to, not browser sync. I don't remember anyway. We did this with film strips where we would look at how the page rendered over time, and we would compare those renderings manually with the renderings of the previous release to see if we had sped up or slowed down how quickly the page would render. Now, a visual regression test might also be automated. We are using here a suite of tools called Applitools that allows us to test in a whole range of browsers and allows us to take snapshots of the page, save those snapshots as a standard that we compare against, and then it renders the new version and says, does the new snapshot look like the old snapshot? Here's where the differences are. And you can exclude certain places, and you can describe them as this is content, so it might change. Any ideas what might go wrong with a visual regression test, or what might be hard to deal with in a visual regression test? Edmundo. Oh, wait, sorry. Go ahead.
Well, I guess if you have multiple people doing testing, you want to make sure you're testing the same browser versions.
Okay, so
Firefox versions match across testers.
all right, and so you're going to configure your visual regression test to run in a specific set of supported versions of your browser, right? Okay, that's a great point. Edmundo.
You get to the point where you have to consider hardware, basically different screen sizes and different processors to be able to render actually. So basically how it looks in a smaller screen and a bigger screen.
Okay. You can standardize that information as well.
Knowing what's a significant visual regression.
Yeah, what counts as a
Date changes.
Date changes. This is a really good example of dynamic data. Okay, and this is the biggest challenge that I have with the visual regression test. We've been working on a product that is significantly date related. It's essentially a report that shows activity with a certain type of user, and what happens is that every day that data shifts older by 1 day, and if you ran the test today, well, and the last test was run yesterday, it looks different. Why does it look different? Because the data got older. Ethan, did you have a?
With your film strip example, if your thing has to talk to some other service and that timing isn't consistent, then you would expect render drift.
Yeah, that's another example of it as well, where a dependency is driving a difference in the rendering that is not significant, that you may not consider to be significant. So in It's useful for a visual regression test. This is why I'm calling out visual regression tests as a class of functional test. It's useful for visual regressions to be run against mock services, mock data that provide a consistent service experience, a consistent data experience. Because you're not interested with a visual regression test, you're not so interested in testing, did this thing get the data that I expected and put it in the right place? I'm interested in, based on the data that I'm providing it, does this render consistently? You're testing a specific portion of the application. Integration tests. This is taking the functional test we talked about to the next level. You may begin to integrate with one layer deeper in your infrastructure. And I'm describing this as different layers. In some cases, you might smash a layer or two together. But the idea is that you're beginning to expand beyond the scope of just one code base into multiple code bases with integration tests, which is where end-to-end tests come in. End-to-end tests test all the way from, we're talking a web application, all the way from the browser client through to the back-end database. So you have specific test clients set up in your data that are used to manage this end-to-end flow, to test this end-to-end flow. What's an end-to-end test supposed to tell you?
The app is working.
The app is working.
All the components are playing nice together.
Okay.
All the code changes work.
All of the code changes that are being released together work together. Because you may be doing a blue-green deploy where you're updating some services and you want to make sure you've transitioned to the new service properly. And so you've got an integration of multiple things that you're testing together. You put these things into a QA environment and or a stage environment, and you're doing an end-to-end test in that environment to try to give yourself confidence that you can go to production with this code and it's gonna work. Now, you'll note as I'm describing this, we're starting out very close to the application with the unit test, and this is providing a core set of confidence that specific functions and modules, specific components are working as expected. Then we expand out again with mocks and with mocks and testing, functional test the application as a unit. Now it works as expected. Then I go out another level and I'm starting to integrate with additional services. These services, this system, this architecture works as expected. And then as I have that confidence, then I can go and put my stuff in a production environment, literally in a production environment. This might involve what's called a canary build, or at Ask we called it last call or first call, because it was the first server we put it on, and then we would run tests against it to make sure it was good to go before we put any traffic to it. And that allowed us to know that, hey, this actually works properly in the production environment. Now we can actually deploy it to production. And once we get into production, then we do production monitoring. This is a form of test that tells us, is it actually up and running? And these can be things like health checks. At OC Tanner, we have a health check URL that we hit that's just we ping it and we know, hey, it's up and running. Okay, it's working the way it's supposed to. We can also do log monitoring here. There's a number of things you can do that constitute production monitoring. But think about production monitoring as part of your test infrastructure that tells you your application and your architecture is functioning as you expect it to function. So the useful realization here, some people will say, yeah, you don't really need to do this type of testing, or you don't need to do that type of testing. And there may be some validity to that. What I think is important is that you understand the use of each type of testing and how to do it so that you get the predictability out of testing that's useful. Different types of tests serve as control groups for other tests. Now, from the scientific method, if you were doing a medical study, what's a control group?
The group that didn't get the medicine to.
The group that didn't get the medicine? Edmundo, did you have
The same thing.
same idea?
Yeah.
Okay. What's the purpose of a control group? Edmundo.
You can compare the results of the people that has the medicine versus the people who didn't. The variance is going to be actually the change of the effect of the medicine.
Right. It helps you to isolate the difference between the control group and the test group, helps you to isolate your learning. What are you trying to accomplish by writing tests? What's the hypothesis you're testing?
Your stuff works.
You hypothesize that your stuff works. So, scientific method, we don't actually prove anything, but what do tests do for us then in that scientific method?
Disprove your hypothesis.
Right. We can disprove that our stuff works. And we can disprove that our stuff works in specific scenarios, which allows us, if we have a failure in the unit test, well, then we know it has nothing to do with interactions with services, and it has nothing to do with interactions with the browser. It has everything to do with just that unit. If we have a failure in our functional test, well, we've mocked our APIs, we're not actually using the browser yet, we're doing some code interactions with it. I know this has to do with the way I've put my stuff together. We had an application that I worked on about 9 months ago. Well, at least when I encountered this problem, it was about 9 months ago. We had a unit test that passed for a controller, and another unit test that passed for a service within a service module within this application. Both of those unit tests passed, and it was everybody. We thought, okay, we've got code coverage here, everything is great. And then I went to actually use the code for the first time. It was written by someone else, and I thought, and then he left the company to go on an adventure. And I went to use this code, and it didn't work. And the reason it didn't work is the controller just passed the query through to the service, and the service returned data that was different than the unit test for the controller said it returned. So we had our running legs and our body doing push-ups, and the head was watching video. The unit test told us that the code worked as it was designed to, as that individual chunk of code was designed to work. But there wasn't a functional test that put those things together that told us that the whole system was working the way it was expected to work. Now we figured that out pretty quickly, and we got it fixed, and it's, and we've since moved on to other problems that we've found in that code base. We're having fun with it and moving forward. But this is what I mean by layers of the onion. You have the unit test that tells you one thing, you have the integration test that tells you another thing, you have the visual regression test that tells you another thing, and in each of these things there's a specific focused group of things that is different, and everything else is the same, so that you know if the failure was here, the problem is here. The problem is the way we use the browser APIs, or the problem is the way this module was written, or the problem is the way these modules were integrated, if that makes sense. So using Satire. Okay, this is where I ran out of time in preparing this presentation, and I'm just going to show you. What can I show you? I'll start with so Satire was yeah. Sorry, this was all set up and ready to go on my other laptop, and then I ended up getting to switch.
Yay.
All right. So, it was awesome. Thank you so much. Where am I looking for? Can I just? I just do that? No, I can't. Never mind. So Satire is built so it can be used directly as a Node module and also with a command line. So you can install this globally as or as an NPM dependency, a dev dependency, and you will have in your path a Satire command that will start up and do this. So you can see one of the things that Satire takes is some configuration here. These are globs. It's looking in specific directories. These are the default globs that it uses, except they don't include your actual file system path. But it looks in mocks, anything under mocks, and anything under test mocks for mock files. And we'll talk a little bit about what those look like in a second. It starts up, and then, well, actually, can I do this? Yeah, except for I'm going to have to. Everything's a little bit slower on this laptop too. It was inexpensive and useful for testing. Okay, so the thing I'm most interested in here, so because this directory is specifically for running the tests that test Satire to make sure it works, because somebody has to watch the watchers if we're talking about politics. You can see I have a set of files here that define my mocks. So under test mocks, as called out here, Satire test mocks, and on port 51, yeah, it's just a little bit harder to do anything on a system you're less familiar with. Okay, let's try green dot ping. Green dot ping just gets served up just fine. Green dot SVG also gets served up. These are, excuse me, go away. These are simply files, right? SVG with a specific command, and the ping is an export of that. Now, also hit string test. Or string.txt. This is a string. These are raw files that Satire is pulling in, recognizing that it doesn't describe a special mock in one way or another. And so it just constructs a mock descriptor for you. Now, if we look at some of these others, we have a JSON directory here. And this JSON directory has in it test JSON. So let's take a look at how that one, what that one's going to do. So this one is it's just going to return the JSON as JSON. It's going to have I'm not hitting this with Postman, so you don't get to see the request headers as well. There's another nice, fun little feature of JSON files in that if I just hit test, I'll get the same thing here. And this allows you to provide pretty quickly, if you have a JSON API, a pretty quick mock response for what you want. Now, in doing that, you'll note I've got this foo JSON and I've got a foo index.js. Now I'm going to come back to that one a little bit. Let's look at a module. And it has an index.js to it. So one of the things that Satire will do, it's going to look in your mocks directory, and if it finds anything that looks like a common JS module, it's going to require that module and use it as a mock definition. If it exports a string, it's going to just make that the body of the response. If it exports a function, it's going to call that function, providing it the request and the response, and let you do some stuff with it. And actually, most of these things are examples of that. So let's hit a module. Let's hit a function module. Function module. Now, a function module was this one, where we got the node request object and the node response object, and we said write to the response the word a function module. Now, we can do some more complex things with this. In this case, what I'm exporting is a more complex descriptor, where I'm saying this is a mock descriptor. This actually is what Satire is building internally when it sees a raw file. It creates an object that has a request key and a response key. The request key is essentially a predicate. That is, it's a set of properties that describe requests that it should match. So in this case, it's going to match requests that have a method of either get or post, and headers that include the word JSON, the accept header of JSON, and an authorization header that has a bearer token. It's going to respond to that with a content type header of application JSON, a status code of 200, and a body that is defined by this JavaScript object that has imaginary true and a value of 2. Now, if for some reason these didn't match, you'll note this is part of an array. It'll move right on to this next module. So there's a failover that allows you to do some things to specifically say, under this condition, respond with this JSON or this response, and under that condition, respond with this other thing. That's a quick rundown of how this works. There's another aspect to this that I guess I should point out, and that is this post file test is a good example of it. Now, this is a function mock definition. It receives the request and the response. And by the way, if you're writing one of these things, this is not a whole lot different than writing your own request handler is in Node. The idea of this is now I've got a framework that lets me just write the request handler. You use this when you need something fancier than what the other capabilities of Satire would provide. But what this particular one does is it allows you to upload a file. In particular, you upload a file as the body of your request, and it writes it based on a name to write, based on a header that you give it, and puts it into actually the same directory. Now, if you take this file and put this anywhere where anybody in the outside world can get to it, you deserve to be hacked. Don't do that. This particular implementation isn't even slightly secure. You shouldn't do that. But for testing purposes, it's useful. And why is it useful? Well, one of the things that Satire does is it uses, are you familiar with watching from Webpack or Gulp? Okay. So Satire is watching the mocks directories for changes to those files. And when those files change, it updates the mocks that it will supply. This allows you to do a little bit of read-write testing. So you can say, I need to test this progression of events, where if I post this to this API, will I then get back this response? That's one of the reasons why you would do a function mock, is it gives you a little bit more leeway with how you would do that. Trying to think of the best way to demonstrate this. I know this works because I wrote tests and these tests work, and I can demonstrate that, but I'm not sure what to do. I guess I would say I would recommend looking into the code to take a look at what this might do.
I have a quick question. Does this will be able to test like Express applications or React applications, or what kind of applications?
So the purpose of using Satire is if you have an application that is calling an HTTP API, right? So in the case of a React application, it's very likely to call an HTTP API, right?
Express too.
Right, and in the case of an Express application, particularly if it's a front-end application, it might call another application that uses connect to a database. Right, or you might have an HTTP front-end on an event bus-based system where the request comes in, gets put on, and it puts an event on the bus, it gets processed by a bunch of other things, another event gets pushed back out, and the API responds. This wouldn't be used to test the event bus. At least Ethan can correct me if there's a way to do that. But it could be used to mock that API so that your React application gets an idea of how the React application will respond to various characteristics of that API. Right, right. One of the characteristics that you can put in one of those mock definitions is time to respond. So a type of testing that I didn't put in here is called load testing. And when we did load testing at Ask, what we did is we took our logs of our production data, and we said, okay, we get this mix of requests, and each of those requests, and our services we know take this long to respond, because we've done load testing on them as well, and we've built them with this many servers so we can get this kind of this sort of parameter. So we know that our servers should respond in this amount of time. And then we mocked out those servers, all of the services that were going to be called by our front-end application, and we ran our log. We used the log of production requests to create a set of tests, and we ran it against our application so that we could get a real idea of how many requests per second our front-end application could actually handle, our front-end application server could actually handle for a given amount of hardware. And then we would scale out the hardware accordingly. So there's a lot of things that you can use testing to do. By testing each of these components in isolation, load testing each of those things, it allows you to properly plan out what your infrastructure looks like. So it is 4 minutes to 8. I'm about to wrap this up. Anybody else have any questions? So Satire is on NPM. So
You can just have the same thing as type Satire. Right now, you're the first.
Sorry. I didn't hear it, so it can't be that bad, right? So this is the GitHub repository. I'll take pull requests if you want it. If we hit npmjs.com. This is Satire. Still in alpha. One of the things that I haven't called out here that I should is Course headers. My coworker went to use my module the other day and realized that he couldn't just run it on a different port than his application because I hadn't accounted for course headers. Now you could implement it yourself, but for this to do what it's supposed to do, it might be nice if it would default to providing some very open course headers. So this is one of the issues that I need to file against myself and add that. It hopefully isn't too hard to add. So far some of these little features have not been difficult. So yeah, Satire lives on NPM. If you have an issue, file it against GitHub. If there's something you like about it, let me know. If there's something you don't like about it, let me know. Be nice. If there's a feature you want, let me know. I will probably respond with, I accept pull requests, at least if they're good. If they're not good, I'll give you good code review, I promise. I'd like to build a community of people around this module. I think it could be quite useful. That's why I built it, and I hope it's as useful as I hope it's going to be. There is another aspect of this that I didn't call out. Satire is able to proxy real APIs and will emit events with the body of those of at least the response, maybe the request as well. I don't remember. And the purpose of that is to allow you to to record your API stuff. I mentioned early on in this presentation when I was at Ask, we did this so we could replay production-like tests and get an idea what was going on with it. Another aspect of this that we are talking about is using Swagger in our APIs and testing to verify that our mocks match the Swagger definition and that our APIs match the Swagger definition, and therefore we have a predictable contract, tested contract that we know is good. Because the API does what the contract says it does, and our mocks say it does what our mocks match what the contract is, and we've been able to test our client against the mock data and know that as long as we have a compliant, as long as our API matches our mocks, we're good, and we have a way to test that. That's still forthcoming. I don't know how much of that's going to be external and how much of that's going to be internal work here at OC Tanner. Mentioning it though because it might be a useful idea to pursue, and it's not our core business, so hopefully it's something useful to the community. Any other questions? Thank you for letting me get up here and present what I've been working on.